Hello everyone, welcome back. Just to check, who wasn't here last week? Okay, a lot of new faces. For those who weren't here last week, how many of you watched the recordings and started on the thing? Okay, just some. Okay. Just letting you know, this is a progressive workshop, so you guys might be a bit behind already. If you guys haven't installed Unity, you might be in a bit of trouble because it probably takes an hour under school Wi-Fi. Just letting you know now. Yeah. But don't worry. For today, I'll be the one teaching. Arnav has a work meeting, so he won't be here today. So it'll be me. I'm Cliff. If you guys haven't seen me before, I'm the current president of NUSGDG, and I have Jordan, our other Unity workshop head. So he'll be walking around. If you need any help, you can ask him along the way. Yeah. So before I start, just remember, help me to scan attendance first. I'll leave this up for a bit, and just to get a show of hands, if you guys need any charging, if you guys need to charge. Unfortunately, for this room, all the charging ports are at the perimeter of the room. So if you need, don't be afraid to move. If a lot of you need, I have some extension cables at the front. Let me know, I will bring them to you. Can? Okay. Okay. 1, 2, 3, 4, 6, 10, 12, 20, 30, 21. Oops. Okay. Anyone still need the attendance code? Okay. Lovely. Okay, so before I start, just to give a reminder, we are doing this workshop in collaboration with NUS Library. So on the 12th of September, we'll be having a 7-day game jam throughout the week. If you are interested, feel free to sign up for it. The final registration deadline will be the 4th of September, so on the Friday, I believe. Yeah, so if you're interested, come and sign up. The theme for the game jam is anything under the Digital Gems collection. I've already posted the link in our announcements chat. So if you're not in the announcement chat, let me know. I can add you in later. Yeah. Okay. So just to give a bit of a recap, I'm not sure how many of you here kind of remembered what we did last week. So last week we did very basic Unity foundation. We covered a little bit about game objects. Game objects are essentially everything that is in your Unity scene. Anything that exists in your Unity scene is called a game object. We also learned a bit about components. So Unity is a bit special. It uses a design pattern, which we call a decorator pattern. Essentially, you can drag and drop as many components as you want into any game object, and it will give that game object whatever functionality your new component has. So you can see for basic cube, it has all of these basic components: transform, mesh renderer, box collider. You can remove them, you can update them, you can add whatever you want. That's kind of the power of components, the power of a decorator design principle. We'll explore a bit more later, but that's what we did last week. And if you want to add your own custom components, we learned a little bit about making your own custom scripts. So this was last week, you guys coded a little bit in C# in Unity using the mono behavior script. By using customizable scripts, you guys were able to make your cubes move, make them jump, make them take damage. So scripts are what we will be using in Unity to give them customizable features. And we'll do a bit more scripting this week as well. So if you guys need any help or you guys think I'm going too fast, later feel free to let us know because it'll get pretty complicated in a little bit. Yeah. And we also covered a little bit of C# basics. So we covered a bit about variables on how to store data in C# specifically. So we covered 3 very basic data types. We have your integers, which are just your whole numbers, your strings, which are anything that are characters or sentences. And we also have floats, which are decimal point numbers. So we had 3 variables for our character. Last week, we added speed, health, and gave them a name, but we really didn't do anything with the name. And don't worry if it's a lot of memorization, that kind of just comes with coding. So we will explore a bit more on data types later. We'll be exposed to a lot of components later. Yeah. So in code, if you want to give your components some sort of variable, this is the syntax or the format for storing data in any script. Okay. So just remember public, the data type, and then the name of the variable, and you can assign it any value to initiate it. And yeah, so we made a player script. All you have to do is drag and drop onto your game object, and it will automatically be added here. And you can see all of the public variables will be shown here. So you can also edit them in the inspector along the way. Okay, and last week we did a very basic WASD movement system. So we just did 4 if checks. Truthfully speaking, this is not very good code, but it's very basic and it's good enough for the games you guys will be making for either library game jam or for level 1 games. Along the way, in probably next week or 2 weeks later, we'll go and discover a bit more on how to write better code. But for today, for last week, we were only interested in getting you guys to see how code translates into your game engines. So very basic code, but don't worry, we will learn how to clean this up in the future. Yeah, so that was the recap. Who here is already lost? Okay, don't worry. If you need any help, just remember, okay, just a small intro again. I'm Cliff, this is Jordan. Just call for us and we'll come and help you. So don't worry, everyone will make mistakes. We're here to learn. Don't be afraid to just be like, hi, I'm lost, okay? Yeah, so this is meant to be a beginner-friendly workshop, but remember, it is a progressive workshop. So if you miss the first session and you didn't watch the recordings, you'll be a bit behind, unfortunately. Yeah, so just to start, before I start off, can I get you guys to open your projects from last week? So last week, for those who have not made a project yet, okay, let me just open my Unity Hub. Okay, for those who have not opened Unity before, so if you weren't here last week, we'll be using a universal 2D project. Specifically, we'll be using any Unity 6 version. I'm using 6.3 for this purpose. So to make a new project, you will see, okay, ignore the warning. Let it load. My laptop is running on overtime. Okay, so just pick any Unity 6 version. If you have multiple installed, just pick the one that has LTS, long-term support, usually won't go wrong. We'll only be using Unity 2D, so we won't be touching 3D for this GameStart. You can make a universal 2D project, name it whatever you want, save it wherever you want, and then just click create project. It'll take about 10 minutes to make the project, okay? If you guys have never installed Unity before, if you have installed Unity Hub, there's this install tab on the left, and you can install the editor. Just pick any of the Unity 6, any 6.3, 6.0, 6.5, all will be the same. Just to recap, I'm using 6.3. There won't be too much of a difference if you use any of the other versions, as long as it is Unity 6. Okay? Yeah. Okay. So I'll let you guys open the projects first. Then main camera. Okay. Okay, so last week we kind of stopped here. So we did WASD movement. We had a bit more time, so we covered rigid bodies and colliders. So just to take a look at what we did last week, we had a simple player cube. We just made a simple 2D sprite. So to make a 2D sprite, just as a recap, to make any object, right-click your hierarchy, any empty space on your hierarchy, and you'll see this create. Everything here is a predefined game object provided by Unity. So if you create empty, you'll just be given a great empty game object that only has one component. But if you make any other objects, for example, 2D objects, 3D objects, so you can see all of the other objects available here. So last week we made a simple 2D square. If you click square, you'll see it's the same as an empty game object. It's just that it comes with a sprite renderer to make it look like a square in the scene. So these are predefined Unity game objects that you will see. Get used to them, go and explore, see what is good for your project. But okay, let me delete. Okay, then after we created a Unity game object, what we did was we explored a bit on the components. So here, these are all of the components on my new square object. So just like I said, components are very powerful. Using the decorator pattern, you can add on and delete as many components as you want on any game object just to give it extra functionality. So for example, you can search up collider in the components and you can find whatever collider works for you. So for 2D, I'll be using box collider, and now my square has a collider. So components, very powerful. We will go and explore a bit more later, but just as a recap, this is what we did. Then after creating a game object, we learned how to create our first script. So as a recap, for developers, for game developers, first of all, ignore this packages thing. Last week, I saw a few of you click on it and then you guys open it up and then it went crazy. So packages not relevant to any of you unless you are interested in editing the editor itself. For us, we will only be sticking with the assets folder. So if you guys get lost in the project hierarchy, just click assets and you guys will be fine. So we made a script folder. To make a script, to make any folder, right click the empty space in the tab. You'll see create folder, and now you have a new folder. And you want to navigate into it, double left click, now you have a new folder. Okay. So for the scripts folder, we made a simple player movement script. To create a new script, you can two methods. Right click the empty asset folder, hover over create, and you'll see this mono behavior script at the top. If you click it, a new script will show up in your folder, and then you can name it whatever you want. And then it'll take about 10 seconds to load and compile. So let it compile. No, I'm a trackpad god. So you work actually. I play also with trackpad, bro. Yeah, so now we have a new script. This is a new script. We explored a bit with our new C# editor. So if you double click any script, it will open up whatever IDE was installed with your Unity. So I'm using Rider. It might look a bit different, but it really doesn't matter. So this is what a basic mono behavior script will look like. It will have the name of your script that you gave it. It will have this mono behavior, not relevant to you guys. It's a bit more computer sciencey. And you will see these two functions, start and update. So these two functions are what we call event functions or lifetime functions in Unity. These functions always run in your game. You don't have to call them. These are essentially what makes your game run and essentially this is what Unity needs for anything to happen in the engine. So in the comment, you can see they provided start is called once before the first execution of update. TLDR, start is called once your project is open. Whenever whoever plays the game, start function will call on every single object that is alive in your scene. Update is called every frame. So this is where usually most of your game logic will go. All right. So Unity will call the update function every time. This is where you perform your checks, your save points, or whatever logic you want in your game. Update is probably the place you want to put it in. So last week, we also showed you, just to give sort of like a demo, we showed you how, okay, debug.log. Hello. And then let's say here, debug.log, I update. Okay. So we showed via the console how these two work. So, okay, unfortunately for Unity, every time you make a small change, you kind of have to wait like 10 seconds, but that's a Unity thing. You can turn it off, but we don't recommend it for security reasons. Okay, so if I play my game, let me clear. Okay. So the button at the top, you'll see that play button. Once you click this play button, your game will game. So if I click player, you'll see it will highlight and then you can drag it, drag it, drag it. But if I click game, I can't move anything. So game is what your player will see when they play the game. And if you click play mode, it will automatically go to game scene and you can see my game go. And okay. So when the game started, you will see, where is my debugs? Oh, I didn't attach the script. Okay, right. Okay, let me turn off all the scripts first. Turn off. Okay, I forgot to mention, as a recap, when you have made a script, there are two ways to attach your new script onto an object. Okay. First way, you drag from your project folder, drag it just into the component empty space, it will be added. Second way is to click add component, look for the name of the script. What did I name it? Okay, look for the name of the script, click it, it will be added. So two ways, either drag and drop or you search by name. Okay, let me delete this one. Okay, so right now the new script that I just wrote, the one with the two print statements are on it. So it should activate when I play the game, and you can see on the console, hi, which is called one frame at the start of the game. So on my start, it will call one frame, it will just say hi, and update calls every frame, and you can see it keeps calling and calling and calling, so the number keeps going up. So this is the number of frames that it has already passed since the game has started. Okay, so that covers creating object, creating script, writing a simple function into your script. and then looking at how it works in your game editor and adding any script into your game object. So this is kind of what we covered last week. Sorry if it's a very fast recap because we are covering a lot today. Okay. Then let me delete this. Remove, done. Remove, delete. Okay. Square. Remove. Okay. 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 And last week, we covered a little bit about your input system as well. So we wanted to know, how do we translate keyboard presses onto something we can work with? So, okay. First, we introduced this keyboard.current system. So this is a very old Unity input system. You just type keyboard.current and make sure you import the package here, Unity engine.input system. If you type keyboard.current, if keyboard.current, all right. So if you type keyboard.current, you will see that there are a lot of keys that you can check for. So backspace, CC, whatever is on your keyboard, you can find here. So this is the most primitive input system. This was very simply only made for keyboard. So if you want any other input system, you have to learn the new input system, which I can show later if we have time. But just for simple games, you can just use this system, keyboard.current, and you can click any key you want. So let's say I put D key. And these are all the functions that you can find. So is press just checks if someone pressed the button. Was pressed this frame, was released this frame. There are many other things, but for us, we probably are only interested in is pressed. So let me delete. So just to read the code in English, update calls every frame as your game is running. At every frame, your game will check if the player presses the W key. If the player presses the W key, let us move up by a certain direction. In which case, last week we did this. We move up by up direction at a certain speed that we put, and then this thing, which is a bit complicated, but just put it for now. I'll explain again later. Okay? So we did that 4 times, one for WASD, and we made a simple WASD movement system. And that was kind of where we left off. We also did a bit of rigid body. So just to show you how it works. Player movement. Yeah. So you can see if I'm pressing A and D, W also works. S will try to push down. So simple WASD system. That was what we did last week. So just remember keyboard.current, and make sure you have this line. Using Unity engine.input system, it should work. Okay. Then the last thing that we did last week was rigid bodies and box colliders. So, okay, box collider here. Game scene player. Okay. So the box collider is essentially Unity's way of giving any object a physical body. So if you want 2 things to touch in the game, you want to see them collide, you need to give both of the objects one collider. So for example, last week we made ourselves one ground and we made ourselves one player. So just take a look at what happens if I remove or I turn off my box collider for the ground. My player just falls through. Right? So if you want anything in your games to be able to interact with each other physically, you need to give both of them some sort of collider. And there, like I showed just now, there are a lot of collider options. Just pick the one that makes sense to you. There's a lot of shapes. So for squares, just pick the box one. Very simple. And make sure if you're using a 2D object, please give it the 2D collider. Don't give it the 3D collider. Because they have different functions, which I will show later. Yeah. So first, the 2 things that you want to touch, both must have a collider component. So my ground and my player both have a box collider. And then we covered rigid bodies. If you want your player or you want any object to be affected by gravity, anything physical, any physical environments, give it a rigid body. So you can see in the rigid body components, there are a lot of physical parameters such as gravity, mass. So you can use this to simulate physics in your games. So if I don't give my player a rigid body, let's say I remove from my player. Okay, wait. Remove from my player. As you can see, I removed my rigid body from my red player, and now it won't fall down anymore because there's no more gravity. But the other scripts that are still working, I can still move it with my WASD. But if I give it a rigid body, it will suddenly be affected by gravity. Oh, I forgot to turn it on. Okay, I lost the player. Okay, turn it on. And that is basically where we left off last week. Anyone is lost or don't remember what we just covered? Okay. I know it's a lot, but that is the pace that we went it last week. If you have any questions, feel free to ask. Please don't be afraid. We are here to help. Okay, so let me reset everything quickly. Let me remove this. Remove component. Okay. Lovely. Testing here. Rigid body. Okay. That works. Okay. Cool. All right. So, unfortunately, we will have to learn some more basic code because some of the concepts today that we will learn requires us to be able to use and write functions. So, anyone here has never heard of a function before in math? Hopefully you have. So functions are very simple. You give it an input, it will give you an output. So we'll try to write that in code today. So just as a question, sort of to see your level of intuition, how many function definitions are in this screenshot right now? How many of you think there are no functions in this screenshot? How many of you think there are one, two, three? Three, anyone? One? Okay, so majority about two? Okay, yeah. So there are two definitions in this screenshot. So just let's go and examine what makes a function definition a function definition. So first off, function definitions are essentially how you write new functions, how you make new functions. First, you need three things in the header. You need public or private or whatever. But for now, just stick with public. Everything, just make public first. Public followed by the return type. And afterwards, the name of the function. If you are curious what a return type is, if you remember last week, we covered the data types, integer, float, string. Those are all return types. Void is a special return type that means nothing, literally return nothing. All right, so we'll take a look at an example later. So this is the header. At the start, if you want to declare a new function, you need these three things: public, return type, name, parentheses, and then the curly brackets. And if you want to use the function, all you have to do is write the function name and then the two parentheses and then a semicolon, and then it will call the function. That is what we call calling a function, invoking a function, using a function, all the same things. And so here there are two function definitions. The first one is start, which is Unity's default function, and then the function that I made, which is test function. And you guys might be asking, why does Unity's start function not have a public or private or visibility thing? So by default, if you do not put public, it will just set it to private or protected. So that is just like a shortcut. But for now, just put public so that you guys can memorize a bit easier. So just remember three things: public, data type, name of function, parentheses, and then curly bracket. Okay, then there's a fourth thing that is optional for all functions. Like I said, functions, we want to give it an input and then give it an output. So how do we make functions accept inputs is we declare the type of inputs we want. So inside the parentheses, what you can do is you have to, for every input that you want, you need to specify two things. First is the data type of the input. So in this case, I want a string. So I'll put string. And then the second thing is the name of the variable that you want to save it as. So here I have print name. I will take in a string and for now, I'll label it a username. And inside my function, inside this curly bracket, you can see I can use the username directly, even though I don't know what is the username. So it's a very generic sort of thing. It's just passing in data to a function and then you can use it inside. And then if you want to call a function that accepts arguments, you need to have an argument when you call it. So inside your little parentheses, this is where you pass in your data in real time. Okay? So just remember, this is optional. Not all functions need arguments. If you don't want arguments, you can just leave it blank. Yeah. And then the last thing about functions is the output. If we want to output something, we need a return statement. In coding or in CS, when we say we return something, it means we're outputting something. So if you specify in your function header that it is not a void function, so in this case, my data type, my return type is a string, I must return a string in my function. In other words, I need this line, return username. If I don't, there will be an error, which I can showcase here. Okay, so public string test. Okay, let's say there's no input. Do something there. Something. Okay, so you can see here, in this test function that I wrote, I specified that I want to return a string. But inside, I did not return any value. In this case, my game won't work. It will return an error. Return statement is missing. So if you want your function to not return any value, just use this special keyword, void. So you don't want your function to output anything, return void, the error will go away. Let's say I want to return a number. So public int. In this case, it's a public function. It returns an integer and it has the name test. Let's say I return something that is not a number. Not a number. I'll get an error, convert expression type string to int. So it will tell you your function is returning the wrong data type. Please change your data type. So if I change it to a number, 1, and then the error will go away. So this is sort of the basics of functions. Okay. All right. Yeah. Okay. And when you output, when you return something from a function, remember, when we called the function somewhere, so we put the name, the parentheses, any arguments, it will output a function. So what you can do is you pretend it substitute your function at that moment, and you can use it for any other thing. So in this case, I returned username. So now my function will become username, and you can use it to save as another variable. But we can try this out later. Yeah. So as a summary, just remember when you want to declare functions, your header, 3 things: public, return type, name of the function, and the parentheses. And if you want to use the function or call the function, just the function name and then the 2 parentheses. For functions that return something, make sure that the data type and the return statement corroborate, so they return the same thing. And you can use your return values for other stuff here. Okay. Okay, so okay, I know that some of you didn't write this script last week, so I'll probably give you a different challenge. Okay, so for now, okay, okay, let me just on the fly give you a new challenge since I think some of you do not have. Okay, what I want you guys to do is write a simple script. For now, if you guys have Unity open, let's try writing functions on our own. Let's call it calculator. Okay, simple CS. Okay, let's just make a calculator script right now. All we want to do is do addition and subtraction. Shouldn't be too bad. Okay, then delete. In the calculator script, I want you guys to write me 2 functions. Add 1, 2, and then subtract 4, 5. Okay, so what I want you guys to do to practice functions is I want you to write 2 functions, add and subtract. They should take in 2 numbers, 2 arguments, and they should return or print a number. So print the result. So just as a hint, let me give you a template for add. Public add. Oh, my AI is doing it for me. Okay. Okay, let's just say number 1, and then number 2, and then return. Okay. So this is sort of this is a template for you guys. You guys can do it for subtract. If you guys want to see it in the console, you can do debug.log, which is our casual print statement. And then we can take a look later to see if it works. Okay. So if you guys have time, I want to walk around and check everyone is okay first. So if you guys are ready, you guys can do the subtract function. If you guys were here last week and you think this is too simple, there's a challenge I want you guys to do. So remember last week we did the WASD simple code. You will realize that we did transform.translate 4 times in our code. So what I would like you guys to do is write a function that you can call inside this if bracket so that you can replace this line for all of the if checks to make it a bit simpler. And there's a hint here. So this is the sort of like a hint of what to do. What you can do is you can make it take a direction, a vector 2, and you can figure it out from there if you want. So now I'll just walk around and see if everyone's okay. Okay? So if you guys were not here last week, you guys can do the calculator challenge first. Okay, then let me walk around.
Does C# always have functions that start with capital letter?
Yes, C# uses something called Pascal case. So
Pascal. Pascal for everything.
everything,
Class.
yes.
That's crazy.
Yeah.
Okay.
Only properties are small letter. Yeah, and don't forget your return type. So if you want to return void or string or whatever. Hey, long time no see. How are you? Welcome back. Why you don't want to be Avenger? Hello, are you okay? All right. Oh, why does your screen have so many red? Is it okay? Okay, position also works. Very nice. Anyone need help? Anyone need help? Raise your hand right now. If you need any help, raise your hand right now while I'm walking around. You okay? Oh, you're way advanced.
I just came like I want to join the club.
Oh, okay. Okay, you can talk to me later. Lah. Oh, are you the Anaf's friend?
That's right.
Yeah.
Yeah.
Okay.
It's my first.
Oh, okay. Yeah. Okay, you can talk to me later. I'll let you know. Hello. Okay. Oh, this is VS, is it?
Yeah.
Okay, so you see this? This is a mono behavior. So you're trying to run it as a C# script.
Yeah.
Yeah, but Unity mono behavior runs in Unity editor. So this actually doesn't do anything. So like I said, the start function is something that runs in Unity lifetime. So it only runs when the game is playing. If you run as a script, it's not playing the game. So you need to run this in the Unity editor.
So like after I save it, I run it here.
You run it there. Oh, we have compiler error somewhere. 95. I think you're missing a semicolon.
Oh, I think it's the other script I made.
Okay. It's in your movement here.
Oh, it's on.
Yeah, 2 keyword. Okay, and should be fine. So, are you new here?
Yeah.
Are you here on exchange?
No, I'm a full time.
Oh,
no, it's students.
You never touched the laptop ever. Yeah, but you weren't here last week, right? I don't remember. Okay, so sorry, because it's a progressive workshop, so you might be behind a little bit. Oh, okay. It's lovely. Okay. If you need any Unity specific help, feel free to ask. Yeah.
How come it doesn't autofill for me like someone's one? So this one is
Yeah, capital L. Okay, because you're using VS Code. VS Code is not configured for any specific language. So you need to install the IntelliSense for C# specifically. Yeah, so if you're using something like Microsoft Code, Visual Studio or Rider, it will come inbuilt. For VS Code, I have no idea what the configurations are. Yeah, so if you're missing the IntelliSense, you can probably find a package somewhere, I hope. If not, let me know. I'll see if what the typos are. Yeah.
Is there like
maybe IntelliSense for C#, hopefully. Maybe they don't like C# in VS. It's possible. Yeah. Everything okay? Oh, okay. Singletons. Hello. Oh, okay, yeah, don't worry. Is this okay?
I'm looking at the previous slide right now.
Oh, okay, okay. Okay, if you need help, let us know. Transform the position. That works too. You can update the position, that's fine.
So one on the slide.
Transform.translate. Capital T. So in C#, we use something called Pascal case. So all functions are capital letters for the first, all words are capital. Yeah. So are you using VS Code? Okay, yeah. So if you use VS Code, there won't be IntelliSense or C#. So you won't see like all the autofill and all that. I'm not sure if you can find a package for you to download on VS Code because VS Code does not cater to a specific language. You'll have to customize it yourself. Yeah. So usually we recommend Visual Studio or Rider because they are both configured for C# specifically.
Oh, is this?
It's this is VS Code. So VS Studio is purple. It's like the same logo but purple. Yeah. Okay. Hello. You okay? Yeah. Does it work? So just remember for functions, we want public, the data type to return, and then the name of the function. So if you want to make a new function, just start off with that first. So just public, data type, so integer, float, or void if you want to return nothing, then the name. Okay. Oh, okay. So you just think about it. What do all of these have in common? They have transformed opposition. They take in direction. So since the direction is always different for every key, maybe you want to pass it in depending on what key they press, because the rest is the same. So you can put it in the function, but everything that's different, you can think of it as passing new data into your function, right? So in this case, your vectors are all different. So maybe you want to pass it as an argument. It's a data your function will need. Then first, just remember, if you want to write a new function, three things: public, the data type, and the name. So you can start off from there. Then you see how you would want to put it in. Yeah. Coming. Yeah, you don't have to make it a mono behavior, but if you want to attach it as a component to any game object, you will need to make it a mono behavior.
so then if I have this code but then it's not attached to any of
It won't run. Yeah, so you need to make it live in your scene. So you need to drag it onto any object you want.
for this one, but I have to drag the calculator.
Yeah. So when you run the game, it will be able to call the start function because it only calls start on anything that is in the scene right now. Yeah. So if you go to your console, you should see your results.
Oh,
Yeah. So for Unity, we use a decorator function, a pattern. So anything you add onto a script, any script you add, it will take on that functionality.
Then what's the difference between mono behavior as opposed to the other types?
Mono behavior is Unity's inbuilt game object class. So are you a CS student?
Yeah.
Okay. Are you familiar with like Java?
Yeah.
Okay, so you know what is the biggest class in Java that covers everything? It's the object class. Everything in Java is an object. Everything in Unity is a mono behavior. That's all. So if you inherit mono behavior, you get access to stuff like transform, components. You get all the support on your inspector. So this is something Unity made on their own. So if you want it to be able to be usable in the engine, just give it, make it inherit mono behavior.
Oh, so mono behavior is the one that has all of the.
Yes, it has all of the Unity functionality.
Oh,
Yeah, if you want it as a normal C# script, just remove the inheritance and it'll be fine.
Oh, I see.
Yeah.
Okay. So the way of actually defining what the function does is that it doesn't go inside the table.
So update calls once per frame, right? So you can think of update as like a loop, a life cycle loop. So any function you call inside update will always be called as long as the game is running. So update doesn't have to be called. Unity will call it under mono behavior. So inside mono behavior, they will have a loop that constantly calls every single start and update function in every single object.
Actually defining the add function.
Yes, you can leave it outside of update, right? So this is like, yeah, you can, if you're not gonna use it, you can remove it. So yeah, so it's a default thing because that's where most things will need. This is a function most games will need. Yeah. Hello, is it okay? All right. Okay, I think most of you managed to do it. So I'll just show the solution first. If any of you have any trouble with the solution, let me know. So it's similar to add. You can literally just copy paste whatever is here. Public int subtract. No one, number two. Yeah. Okay. So the only difference is one is add, one is subtract. So just change the plus sign to minus sign and it will work. And don't forget, like I showed just now, if you want the script, you want to see this in your console, start only calls, the start and update functions only call on any existing Unity object. So you have to drag it onto any object on your scene to see the function run. So in this case, if I drag calculator to my player, if I click on console, you'll see my results. And so if you don't have this calculator script living on any object, you will not see the results on your console. And okay. Okay. Lovely. And some of you asked just now why return in. This is a design choice. It's really up to you. If you don't need the function to return anything, you can just put void and remove the return function. It will still run normally. What if you want to return in? So returning a function just means that it outputs something. So you can use it to do other stuff. So you can start combining the operations. So for example, you can do add 1, 2. Wow. I don't know why I would add again. It gets weird, like, it gets weird. Let's just go crazy with it. All right, so you can see in functions, if you have an output, if it returns something, you can essentially it replaces the call with whatever value it outputs. So 1 minus 2 will subtract, it will return -1. So in real time, this is kind of what happens. It will change this to -1, -1. And then add 1, 2, it will call, it will go through this, it will return 1 plus 2. This will be replaced with 3 in real time. You won't see this, but it's behind the code. And then finally, it will do one more add call. So if your functions return something, you can use it for other functions. You can use it as an output. So we won't be doing this too much later. So you can ignore it. But if you want to put it as a void and return nothing, that's fine as well. Okay. Then some of you were doing this just now, this challenge. Okay. Okay. Some of you were doing this challenge just now. So some of you asked, how do you know what arguments to put inside your function? So what we can do is we can take a look. For functions, what we want to do is essentially what we call refactor or substitute things that are always being put there. So things that are repetitive, we want to put inside a function so that it becomes reusable. So in this case, if you see our transform.translate line, the only thing that differs for every if check is the vector. So for W, I want to use vector up. If for A, I want to use vector left. d vector right, s vector down, but the rest is the same. We translate, multiply by speed. So what you can do is you can make it change by just sending the vector as your argument. So for every key, you just send the vector as the argument, because that is the only thing that is different. But inside your function, you will see that the code is essentially the same. So now in the future, if you want to update the way your movement system works, you just have to update the function rather than every single line where translate was called. So in general, for design decisions, when you guys are making a function that is trying to replace a very repetitive piece of code, if you realize that some of the things in that line are the same, put it in your function. If they are different, you can think about putting it as an argument instead. Okay. Anyone want to take a photo? Okay. Okay, cool. Okay. Sanity check. Everyone okay? Anyone need help? Okay. Okay. Lovely. Oh, my thing's not highlighted. Okay, never mind. So we'll be doing collision. I'll be going through collisions. Collisions are very useful in Unity. If you think about any game, you want to know how, when two things touch each other, how do I make something happen? So you think about checkpoints, you think about taking damage, spikes, obstacles, hitboxes. You will need to know how to use collisions. So simple example of collisions, two things touch each other, they get knocked back, right? So we did this a little bit last week with our rigid bodies, but we'll go more in depth right now. So remember, every object, if you want them to experience collisions, give them some sort of collider component. For 2D, just use the 2D variant. So there'll be a 2D at the back of the component name here. So if I add a component, if I search collider, you'll see all of the different types here. Feel free to explore, but today we'll only be using box. I don't think we need anything more. You're only using box. So all the different types just gives you different shapes for the collider. So box gives you a box, capsule is like a pill, circle gives you a circle collider. So all it does is the shape. But here, okay. Under the collider component, excuse me, under the collider component, you will see this edit collider. If you click it, you will see this green outline suddenly show up and you can edit the size of your collider. So if you want your player to have a bigger hitbox than usual, you can just give it a bigger hitbox, drag style. Or you can offset here via parameter values, but it's not very intuitive. So usually I recommend just click edit collider and then drag to your HUD's content. Okay. So that's how you change the shape and the size of your colliders. And remember, if only one object has a collider, it will just fall through or go through the other object. Okay, reason why I'm teaching you guys functions is because unfortunately we will be using a lot of them in our game code. So this is taken from the Unity documentation website. In particular, if you want to use collisions in your game, there are only 3 functions you need to know how to use. OnCollisionEnter, exit, and stay. There are 2D and 3D versions. For 2D, just add a 2D behind the name. So essentially, for collisions, there are only 3 points in time where we are interested in for collision. First, when the objects first collide, so the first point of contact, can we make something happen? That is on collision enter. So that is the first frame in which the 2 objects collide. On collision exit, when the 2 objects which are touching, when they stop touching, so they are separated, can we make something happen? That is on collision exit. And on collision stay, while they are still touching, can I make something happen? So that is the 3 functions we'll be using. So in your code, it will look something like this. Let me move to my player here. Oh. Okay. Here. So just like your start and update functions, these are Unity event functions. You do not have to call them. All you have to do is define them. So they are always called by Unity. You just need to give it a definition so that when Unity calls it, it knows what to do. So just like your start and update, okay, let me just remove everything first so it's clearer. So like your start, it's usually after the first curly bracket, after your mono behavior. So it's within this indentation. Your collision functions are all in the same indentation as your start. So it should look like it's all one vertical line, one block. Let me. Okay. And okay, just now I talked about public and private. It really doesn't matter. You can put public, it will still work. You can also just remove it. It will still work. But just for your memorization purposes, just put everything as public. Nothing will go wrong. Okay. Okay. And one thing you will see is that all of the collision functions take in one parameter, one argument. This is the other object that is being touched during the collision. So this is not something you have to fill in because you don't have to call this function. This is data that is passed to you. This is some data that you can use in your function for whatever you want to use. So just remember, as long as if you're using collision 2D function, so here, OnCollisionEnter 2D, any object that has a collider 2D, it will be able to be detected by this function and it will be passed in as a collision 2D object. And you can go and find out the types of data that is available. You'll go and explore later. All right, so let's try to use the function to see how it works in the game. So for now, let us just write a simple piece of code. You can put this in player movement, in player, you can make a new script called collision detection. It's up to you. I'll just be putting it in our player movement or player script. So all you need to do is you type, okay, let me just delete everything. Yeah. Okay, so let's all define the function first. So just remember the names are here on documentation here. On collision enter 2D, on collision exit, and on collision stay. So let's do enter. Public void on collision enter 2D. It takes in a collision 2D, and then you can give it whatever name you want. So I usually, most game developers will put other because it's easier to read in English. Right. So first, let's define the function by putting the function header. So just remember public data type, name of the function, and then any arguments. Okay, so let's just see if we can do anything with it. For now, if you were here last week, we gave our player this health, right? This health variable. So let's do something with it. Let's say if my player touches any other collider, let's reduce its health. So let's do health equal health minus 1. So on collision enter, when my object touches anything, I want to reduce my health by 1. That is essentially what this piece of code does. Everyone okay? And let's see this in action. Compile. Main camera player. Okay. Oh, I don't have a jump button. Okay, never mind. Okay, so take a look at this in my player script. At first, I started with 10 health. So remember, the ground already has a box collider. So it will be counted, it will be detected by your collision function, which we wrote. So if I jump, every time I jump and I touch the ground, you can see my health going down. So this shows that your collision function is working. Okay? So you can go all the way down negative. So you guys can do the same thing for exit and stay. You guys can go and try and play around. But right now, this function isn't very useful because why would I want to lose health whenever I touch something? We just implemented damage, but what if we wanted to lose damage to a very specific type of object? How do we differentiate the types of objects that we collided with? What we can do is we can introduce a tag into our game. So by default, all Unity objects have no tag. So the tag can be found in your inspector if you click on any object. Let's say, so camera, you'll see there's a tag. Light with no tag, player, test, ground. So the tag is over here, right below the name. And there are a lot of tags that are pre-built or provided by Unity. But let's say you want to have your own tag. All you have to do is click add tag, click on the plus, and then you can name it whatever you want. So for example, if I want to have a spike, I want to make a spike. So I just call it a spike. Click save. So now you have a spike tag. So if you try to add a tag, you'll see it's now one of the options here as a taggable item. But let's try to make a spike. So I'll create a triangle here. Triangle. So let's call it spike. Okay. Let me move it to the ground. Yeah. Yeah. And so remember, if you want your object to be detectable by the collision function, don't forget to give it a collider. So in this case, I'll give it a collider. It's not really a box. So polygon. Polygon collider. It should look like a triangle. Yeah, okay. Okay, so you can give it a box collider or circle collider or anything. I'm giving it a polygon collider since it's not really a square or a circle. So now it has a collider 2D. Since it has a collider component, my function will be able to detect and pass in that data to me here. And don't forget, we want it to be identifiable. So let's give it a spike tag. So from now on, when we are going to check via code, we'll be looking for this spike specifically. Okay. Okay. Everyone okay? Okay. So we kind of already have the logic for damage. If we touch anything, reduce the health. But we want to make it more specific. So we want to check if it is a spike in particular. You can use this function called, okay, how to make tag. Okay. We'll use this function called CompareTag. So it essentially does whatever the name says it does. It just compares the tag with whatever you have decided to compare it with. So for example, if other .game object you're comparing, oh, it fills it in for me. Yep. So if I read this code out in English, if the other object, then you want to get the parent object so you can get the component. If the game object of the other object, the other collider, has a tag that is called spike, then I want to lose health. So that is how you use compare tag. You need other and you need to get the game object. You need to get the game object first. Then you compare. Can you send the slides via Telegram? I think can just send. Yeah. Yeah. So we can see how it works in game. Okay, let me give my spike a color so it's a bit easier to see. Color spike transform. Let's make it pink. Why not? A bright purple. Okay. Player. Okay, so you can see now, because I checked specifically for the spike, whenever I touch the ground, my health doesn't decrease anymore. But if I touch the spike, my health will go down. But let's say I remove the tag from the spike, so I make it untagged. Take a look at the player health here. I will stop losing health. So you can use compare tags to check for a specific group of items. You can even have multiple tags, multiple spikes rather. In fact, you can even give your ground the spike tag, because why not? And now, if I touch the ground, I will lose health too. So tags are a very powerful way to identify collision objects. Quite one of the simpler ways. There are many other ways, but this is probably the most intuitive way for beginners. Yeah. Okay. So is everyone okay? Everyone okay? Do I have a sanity check? Yeah. So add a check for the tag by other.gameObject.compareTag. Okay. Anyone needs help? I'll walk around now for a bit. I'll show the code here in case you are interested. All good. Anyone need help? Raise your hand. You don't have to put it in update. So it is a Unity event function. You can put it in the same indentation as update. So yeah, so that's fine. Yeah, that's fine. Yeah. Yeah, okay, perfect. Do you have a debug log in your collision? Oh, because it's a else, is it? So you need to wait for negative health. Oh, okay. Let me see. Maybe it's like low. It's being hidden by all of your vector Log. Yes, it keeps running because it's on update, right?
As it start. So
Ooh.
yeah, it's fine. I'll just comment them out and then.
Yeah, why is it running so much?
By right should.
It shouldn't. It's probably somewhere else then. Mind if I double click? Oh no. Which script here? Oh, it's on update on your player movement. Okay. Anyone else need help? Sorry, I'm coming. Hello. What's up?
Report youth isn't changing. We just have a clock tick here. Just
Oh, as in not changing.
like
Oh, this one.
Yeah.
Okay. Let me see. Okay.
this tag is finished because I
That's your collider. What is it? Okay. There's a player collider has a tag. It is collided, but then it's starting. Oh, then we go behaving. On player something 2D. Every time your players now. It has a collider. But it is a bit different.
also this is an even one to set. So that's the one.
Okay. By default, Unity will impact the value. So if you want it to be the same as your code, I think you just keep it as private. Yeah, so it won't show up and you can't edit it. Okay, minus equal 1. It should work. Because it just take minus 1, right? Oh, you're using the wrong function. On collision.
Oh.
Yeah.
What's the shortcut to play?
Not sure. Oh, I think it's compile.
Oh, yes.
Yeah, so just make sure to check the function name. Maybe I should introduce Unity documentation. Oh, it works now. It works now. Okay, very nice. Hello. Any help? Yeah, well, soon, bro. You're watching a movie today. All good?
Is there an ID recommend?
If you want to go specifically into game dev, you can use Rider, RIDER. That's specifically made for Unity. If you want just a generic C# Java IDE, you can use Visual Studio. So not code. Visual Studio code is blue. Visual Studio is purple. Yeah.
The no autocomplete is kind of.
It's very annoying, right? Yeah. I would recommend Rider if you want to use it specifically for Unity. Because it will show you a lot of other errors that is not found in Studio. Yeah, so that one's very strong. And it just became free 2 years ago. So it used to be a paid thing. It's very strong. No. What's up? Everything? Oh, okay. Let me see. Maybe it hasn't on start find rigid body. Does your thing have a rigid body?
So
Okay. So player, just add component and then you search rigid body. And don't forget to give it a collider also. Yeah. So rigid body just makes it simulate physics. So like starting gravity, you see it fall down. Right? So collider is the body. We need all objects need the body. If need space, so I think where to go again? Okay. Unity engine. Wait, you do have the engine though. Okay, first for Unity, all of your scripts need to be capital letter. Yeah, okay. Yeah, so this thing has to be the same as all this. All script will be able to identify. So they can try.
the rigid bar.
rigid body to D. If I just remove the line, will it work? Because I'm not sure. Let's comment it out. Okay, so something's wrong with the rigid body line. Yeah, no collider on the ground. So you're ground in the player, hit the collider. Yeah. 830. Fine. Yeah, you can slowly test the walk around a bit. Everything okay? Okay. Alright, nice. All okay? All okay? Yo, what is going on here? Oh, do you not want it to rotate?
That's not yours.
Okay, because your rigid body simulates physics, right? So it will try to preserve rotation. If you want it to never rotate, you can just freeze the rotation here, and then it will stick to that sprite. Yeah. So you can try freeze rotation and play the game. It shouldn't rotate anymore. Right? Yeah. So rigid body tries to simulate physics. If something gets collided, it will fall over, so it will rotate. But if you don't want it, you can. Because there are two colliders, you're trying to force the collider into the other one, it's pushing it out. And usually it shouldn't be possible, but remember our player script. We are doing so where's the move function? So you're doing transform the position. So you are essentially hard coding the position, you're making it teleport. It's teleporting into the body and then getting to the top. There are many other ways to make it move. Usually we do rigid body or add force, so it won't teleport. But you can. Yeah, so you can explore, see what works better for your game. Okay. Okay. Everyone okay? Last calls. Okay. Okay. Oh, help. Oh, okay. So what collider are you looking for?
I have it as a try.
Okay, so you're using a box collider, so it will be a box. So you just have to choose the different type. Yeah, so you go collider. For triangles, you can use polygon. Yeah, so it'll be a more better shape. Nice. Okay. Okay. I'll move on first. I think everyone should be all right. I hope. Okay. So just to carry on, cause we have like 1 hour left. I'm gonna explain triggers very briefly, only because triggers and colliders are essentially the same thing. So the only difference between trigger and collision, trigger, you can think of it as like an aura or force field. It is an area in which you will keep checking for the collision, but you can move through the trigger. So I'll just show you a demo. I think it's easier to see. Okay. Here. Okay, let me make this spike super huge. All right. So to make a collider into a trigger, all you have to do is click this is trigger function. So once you turn it into, you click is trigger, it'll become a trigger. Very simple. And for triggers, very similar to collision, but the only difference is the functions that check for triggers are different. So just now we use the top three triggers, you just change all the collision into trigger and then it will work. And something different is the argument. The argument for triggers is not collision 2D, the argument is collider 2D. all right, is collider 2D. So if you saw just now, OnCollisionEnter takes in a collision 2D, but trigger takes in a collider 2D. There's a difference. If you want to know the difference, collision 2D has a collider 2D. It just has other data as well, including impact frames, but that's not something you need to know. We can explore that in your free time. So just if your function is not working, very likely you are taking in the wrong parameter. Okay? So it's the same to set up a trigger. It's the same thing as your OnCollisionEnter, but I'm not gonna set it up on my player because I don't want my player to be a trigger. What I'm gonna do is I'm gonna make a new script for triggers. So what behavior? Okay, let's just call it damage. Okay, healing aura. Let's do healing aura. Okay, not trigger. Okay, so for my aura, let's say I want to make it a circle. So I'm just gonna create an empty circle. Here, circle, circle, circle. Healing aura. All right, I have a healing aura. Let's make it green for healing, and then maybe a bit less, like a bit transparent because it's an aura. And then I want to make it super huge. So let's just. Okay. Okay, so don't forget, you need to scale down this so I can jump over later. Okay, don't forget, triggers and colliders, you need the collider component. So give it an appropriate collider, in this case, circle, and then just take its trigger, it will become a trigger. Okay, then healing aura, let's give it the script first. So now I have a healing aura script. Okay, so to set it up, it's the same as your collision. You just need to put the right function name. So public void on trigger enter 2D. Collider 2D, other. Okay. For now, let's try to reuse what we just learned. So let's give our player a tag so that this only heals our players and not the spike accidentally. So let's just give it a player tag. So now my player is tagged with player. When the player enters the trigger, if other dot copy, compare tag is player, let's heal it. So it's public property, right? Okay, cool. So other dot get confirm player dot plus equal. Wow, okay, now I just do plus equal 1 now. Okay. Wait, let me explain this piece of code. Okay, so when your player touches the trigger, it will be sent in as a collider 2D. But this collider 2D specifically refers to this component. Compile. Okay, so on your player, there's this collider 2D. This component is what is being sent into your code, right? So this collider 2D other, this component specifically is what is being sent into your function. If you want to change the player's health, you need access to the player script because that is where our health is being stored. So what you need to do is you need to get the game object, which is the parent of the script, get the component player specifically, access the health variable, and then you add it. And then you do plus equal 1. It's the same as just doing health plus equal health plus 1. But I don't want to rewrite this whole thing. So this is how you access other scripts. I was going to teach this later, but I forgot this was part of triggers as well. Okay. Yeah. So it's a bit long-winded. If it doesn't make sense now, we'll go through it again later. It's like literally the next slide. Yeah. Yeah. So just to re-explain, this collider 2D, what it detects is it detects this component in particular. You want to access the health of the player, so you need to get the script, a different script on the same component. So you get the parent object, then you get the component from the parent object. In this case, you want the player script. Then you can access the health from the player script. All right, so if I were to try it, okay, let's look at the player. You can see my health goes down when I touch the spike. Okay, how do I jump? And then when I go into the healing aura, you can see I don't get bounced off like the spike. On the spike, I cannot go through it. But my aura is a trigger, so I can walk through it. But my detection is still detecting my player, so my health is going up whenever I pass by. If you want the aura to heal while you are inside the aura, change from OnTriggerEnter to OnTriggerStay. Stay will detect whatever is inside during the collision. Yeah. So you can see my health going up, but I can go through the object. So that's the difference between a trigger and a collider. They both detect collisions, but triggers can be passed through. That's all. It's like an aura, like a force field. So usually for beginners, what you guys would probably use for triggers are stuff like checkpoints. If you pass a certain area, maybe you want to change a level, you want to save the respawn point. This is usually what triggers are for. Then, okay. So if anyone want to take a photo, everyone okay? Right. So it's a bit different from your player. Yeah. So for triggers, it's a bit different because you have to access another script in the code. So you have to get the script first. But we'll go through this later. Okay. Do you have to go? Okay. All right. So just remember on collisions, 3 functions: on collision enter, stay, exit. Triggers, 3 functions: on trigger, stay, exit, and enter. Collision functions take in collision 2D. Trigger functions take in collider 2D. So those are the differences, but the uses are the same. And make sure all of them have a collider component. All of them have a tag if you want to differentiate based on different objects. Okay. Everyone okay? Everyone need time? Okay. Okay. Okay, this is a bit more useful, I would say. References. Okay. So far, a lot of the code that you have written modifies properties of that script itself, of that game object itself. But sometimes you want to write code that affects other objects. So if my player shoots a gun, it will spawn a bullet and the bullet will cause something to be destroyed. So you want to be able to affect other objects in the script as well. But how do you access the properties of other objects? We saw just now via the trigger. But so far, we've only explored a little bit about modifying yourself, the game object itself. So in your player movement, your WASD script only makes itself move. Space makes itself jump, and on collision, it makes itself lose health. So how do we affect other game objects? There are 4 ways. Inspector. So you drag the game object in via inspector to get access. Get component, which we have been using so far. Triggers and colliders. It gives you the game object itself as the argument. And singletons, which I will not cover because it's a bit too complicated for everyone right now. So let's go through the inspector method. Okay, so just now, so far, we've only done public variables that are basic data types. So basic in the sense that they only can be modified by value. So integer, strings, floats. You can see that inside your inspector over here, all of the basic data types, you can just hard code the value. But in code, we have something called reference types. Reference types are, okay, I don't know how to explain to beginners. Reference types are just very complicated pieces of of objects that cannot be defined by one value. So for example, rigid bodies, as you have seen, rigid body. The rigid body script or component has all of these different properties. You cannot just fill in one value and expect it to represent all rigid bodies. So if you want to pass in a reference type, you have to pass in drag and drop the script. So let's give it a try. So in your player script, what you can do is you can have a public rigid body. So this data type, very simply, is literally just the name of your component. So let's say I want to pass in a rigid body 2D. the name of the component is rigid body 2D. So you just type the data type as rigid body 2D. Then you give it a name just like any other variable. And what this does is in your player script, so under player, you will see this new variable, new inspector field. So it will, if you try to click this button, it's a different kind of selection screen, but I'll ignore it. I don't really use it myself. What you can do is to fill it in, you either drag and drop the rigid body you are interested in. So you can drag from the inspector, fill it in, or you can pass in any object from the hierarchy. It will autofill based on the component that you are looking for. So if I delete the rigid body, if I drag, so my body, my player has a rigid body. If I drag it in, it will autofill the rigid body contained by the player. And now you have access to the player's rigid body script via inspector. So essentially, it does this thing. It does get components job, but using the inspector instead of using code. And this is quite powerful because get component only works on the current game object. Inspector rigid body, if you drag and drop, you can drag and drop rigid bodies from other game objects. So for example, if I, let's make another game object. Okay, I'll just make another square. Let's say I give it a rigid body 2D. So now my random square has a rigid body. So let's say I want to access the square's properties or rigid body. I just drag the square in, it will autofill. Now I can modify my square in code, even though it is a different object. So this is usually how most people would use their, how most people would get references to other components on other objects. You just make a public variable for that component, drag and drop on your inspector based on what is in your hierarchy. Can? So you can do this for many other things. So okay. Anyone is lost? Okay, wait. Anyone lost? Anyone like super lost right now? Everyone get the intuition of what we're trying to do? We're trying to modify other game objects, components. Can? Yeah. So drag recommended method, just drag from the hierarchy. Second method, you drag from the inspector, but this is not really it's very difficult usually. Okay, so it does the exact same job as get component. Only difference is you can use it to find other game objects as well. So via inspector, you can drag other game objects other than just itself. Okay, so okay, me change. Let's ignore that for now. Okay, so for the healing aura just now, what we did was we access the player script on the object by using get component. Let's try to see if we can make it work using a reference just to see the concept of how it works. What you can do is you make your public variable for you to drag into the inspector. So public. So in this case, I want the health component. So I want to get the player, the health, and the player component and the health. So I will get public player because that is the name of my component. And there's a called player. Okay. We probably don't need this check anymore, right? And I might just put a check in. Okay. Still need, right? Yeah, okay. Because if not, it'll just heal random stuff. Okay, yeah. Okay, so what you can do now is this player, you can just access the health of the player and then you just do plus equal 1. So instead of getting the reference to the player script via get component, we're gonna use it via inspector. So if you do this, okay, compile. Now my healing aura script, you will see there is this empty script, empty slot for my player. You can just drag your player in, it will find the player script and it should work. So now if I look at my player health, my health is here, 10, touch the spike, lose 1. What is happening? Oh, my player is flipped. Okay. Why is my jump button now? Okay, I'm cheating. Okay, the spike doesn't exist. Okay, so now look at my player health. Oh, it's not working. Oh, there you go. Yeah, so you can see I can modify my player script even though it is a different game object by just dragging in the player script via variable. So there are two ways. First way, you get via get component. So that will find based on what game object you have. And then the second is to drag the player script by making it a public variable into your inspector. So just as an intuition, just remember, if you are looking for a component, it is usually just the name of the script. So whatever is here. So if I want a sprite renderer, I will just change this to public sprite renderer. So anything in the component, the name of the component is literally what you just have to put as the data type, the reference type. Okay, so that is the intuition you are looking for. Okay. Anyone don't understand? Everyone understand the intuition at least? We are trying to modify other game objects. All right. So this is about modifying other game objects. Okay. So now that we understood colliders, triggers, and references, what you can do is you can try to make a spike trap that only appears when you are nearby. So a spike trap that is like, you can think of like those very old dungeon traps that pop up. So you want to make it, you can make it a trigger that checks whether the player is nearby and then enable it to make it appear or not. Something you can try. And make a color changer when you touch a certain thing, object collision or trigger, change the color of the sprite of the object touching it. So you can try using the triggers and colliders to see if it works. But I think I'll move on for now because we are running out of time. Okay. Who really needs help? Who needs more time? I will allocate time now. Anyone? No? Okay. Okay. Last but not least, UI UX. So UI UX usually stands for user interface. This is more relevant to games that for people who are interested in making point and click. So if you're interested in buttons, text boxes, this is probably more applicable to your game. So UI UX, user interface, user experience, you will hear this a lot in terms of like navigating websites and all that. So not a very uncommon term. So for now, let's try to learn UI UX by just making a main menu from scratch. Okay, so let's make a new scene. So in your scenes folder, this is by default. To make a new scene, right click the empty space in your asset, hover over create, and there'll be this scene. So you hover over scene and then scene again. So you click scene, a new scene will appear. So you can say main menu. I already have a main menu, so I just call it menu. And then you'll make a scene. And if you double click, okay, I'll just save. If you double click, you get a completely new level. So scenes in Unity, you can just think of it as levels. So you want more levels, make more scenes. Okay? So anyone trouble? Okay. So in Unity, if you want to make any UI, UX, any interactable point and click, what you need to do is you need to create something called a canvas. So right click your hierarchy. You will see this UI canvas option, hover over it, and you'll see all of these things. So for now, let's just go simple. Let's have an image just to make like a background. So an image, and you'll see something like this appear. Everyone okay? So when you click, when you make a new canvas, there are two things that will always appear. Your canvas and your event system. If your UI is not working, very likely one of these two components are missing. The canvas is your overlay area. This is like a filter. This is the area in which your UI will live in. The event system is Unity's way of detecting mouse clicks and button clicks. So if you don't have an event system, please add it in. It's still under UI canvas and there is this event system here. So in the case where it suddenly disappears, sometimes, it just happens sometimes, don't, most likely you are missing an event system if all your buttons are not working. Okay, so for UI, you need these two, a canvas and an event system. If you look at the canvas, you will see very different options. The components are totally different. It has a transform, but it's not exactly like your game scene. So your game objects have this transform component. Your canvas has a rect transform. So to understand canvas a little bit more, okay. Unity canvas, you can think of it as like a filter. It doesn't live in the 3D space of your game engine. Rather, it is like a filter that will be pasted over your game. So if you want to put stuff like a title, your score, your health bar, usually it will live in your canvas and it will be pasted over your game. So it will not be affected by stuff like physics, by other objects. It will just be pasted over like a sticker. Okay? So one thing that you will see, okay. One important thing is in your game objects, sometimes, yeah, so sorry. So in your game objects, you will see a lot of components that we have gone through just now. So, okay, let me make a simple square just to illustrate. Okay, so you'll see stuff like sprite renderer. By now, hopefully you will notice sprite renderer is sort of like the image version of a game object. So this is how you change the sprite, the image. You can drag and drop a cat. You can make your game a character a cat, that kind of thing. But canvases have their own unique components. So instead of having a sprite renderer, it has something called an image or raw image. So if you scroll create, you will see that it has its own version of components. My recommendation when you are making a UI, don't use the add component button here for your UI, for anything on canvas. Don't use your add component because a lot of the components don't work for your canvas. There are very special components that work. And if you use add component, I'm afraid you might add some stuff that are not supported by canvas. So if you add an image or like a sprite renderer, if you add a sprite renderer, it won't do anything. This won't show up. So you can edit, but it just won't work. So if you are interested in knowing what works on the canvas, in the slides I put the documentation. These are all of the components that work on the canvas specifically. You can go and see and explore. But today we only go through a few: buttons, text, and images. Okay, just those three. Okay, so another thing you will notice is your game camera is like that. It's that small. If you double click your canvas, you double click any item in your hierarchy, it will zoom in for you. So if you are lost, just double click the item, it will bring it to wherever the item is on your scene. So that's like a little hack. Okay, if you double click your canvas, you will see that it covers like a different part of your screen. So your game camera is not included. So this is what I mean by your canvas and your game live in different spaces. Your canvas is like a filter. It is not part of your game. It will just be plastered on to your game scene. So if you double click canvas, you'll see it covers a pretty big area. Okay, but before we move on, let's take a look at this canvas scaler. A lot of computers have different screen sizes. So what usually for most games, you want to use this option, scale with screen size. So this will make sure that your canvas will fit into whatever different device your player is playing on. You can leave this as match width or height. It doesn't really matter. And for your X and Y, X is your width, so your horizontal, Y is your vertical. This is your resolution. If you are making pixel art games, you would probably start small, so maybe 320 by 180. If you are making a game, 180. If you are making a game for native resolution, usually most game developers will go 920 by 1080. And it really doesn't matter what the resolution is, as long as it is in the ratio of 16 by 9. That is the native resolution of all devices in the modern era, at least. If you don't scale your screen, your game will have black bars. So that is something you probably want to avoid unless it is a stylistic choice. So just leave scale with screen size, and then the reference resolution, I'll leave it to you. Most people will put 1920 by 1080. And just to see the differences, So in Unity, you can actually test out different screen sizes in your game scene, in your game tab. There are many different aspect ratios you can test. So these are all the common ones. So this is like HD TV, this is 4K TV. If you're making like a game for big TVs, big screens. Free aspect lets you drag and drop. It will be based on your editor size. So your UI will change based on whatever size is your editor. But usually we just stick with 16 by 9 because that is the resolution we want to work with. And okay, so now we added the image just now. Let's fill in the canvas. So if you click image, or I named it background, it will have this rect transform component. If you click this little anchor image, there are all sorts of options. We are only interested in this, the stretch image. So if you click stretch, it will stretch for all resolutions, and you want to make sure that all of your variables are 0 here. So you can see it will fill up my entire green screen, and it will fill up my entire screen here. So for background, if you want to make a simple background, usually click stretch, which is your bottom right, and make sure everything is 0, so there is no offset. Anyone lost? Anyone need help? Okay. So Unity is very nice. For canvas images, it will render any sort of modern supported image formats, JPEGs, PNGs, SVGs, so vector art also can. So this is just some random cat picture I found on Google. All you have to do is drag and drop it into your source image here, and it will change my screen, my background into a cat. So you can find any image you want. This is basically the easiest way to make a background. Just draw the background, import it into Unity, so you can drag and drop. Okay, let me just show how to import. Okay, anyone have a background in mind? Rainbow. Okay. Please adhere to your copyright laws as you do this. Okay, so save image, BG test. Okay. So Unity's project tab is kind of like your Windows default or your Mac default folder. You can literally just drag and drop stuff into it. So for example, if I drag and drop, it will show up. So now you have a new item in your Unity. So that's usually how you can import sprites into your editor. So if I change my background into the rainbow, now my background is a rainbow. So images, very intuitive. Just make sure the size is correct, make it stretch, and then just change the image. Everyone okay? Okay, so that is literally background. That's how you do a background. Okay, slides. Screen size, anchor, take stretch, 000, apply. Okay, yeah. Okay, so that's image. Anyone need help? If not, I'll move on to text. Okay. So let's say for your main menu, you want to add a title. Very simple, create a new one. So back to UI canvas, right click hierarchy, UI canvas, and click text. And you get Text Mesh Pro. And you will get this text component. If you are importing text for the first time, you will get this little pop-up. Where is my pop-up? Whoa, okay. I don't have the image of the pop-up. Yeah, I didn't paste it. Okay, never mind. If you are putting a text image for the first time, you'll get a pop-up that says import TMP essentials. Just click import TMP essentials. That's essentially you're downloading all of the fonts Unity has by default. So just click that if you see a pop-up. Okay, let me add that in later. Okay, and if you import, it'll take about 30 seconds. You will see this new text appear in the middle of your screen. So here, yeah, text component. Everyone okay? So let's explore the text component a little bit. So it has like, if you have ever used Google Docs ever, your text component is literally just a Google Doc. Same stuff. You have justify, inline, your font sizes here. So you can change the font size to whatever ridiculous number. You can drag the area like a Google Doc. You can make it bigger. You can change the text here. You can change the font, so you can download fonts and import them into Unity. Yeah, so you can bold, italic, underline, strike out, that kind of thing. So it's just all point and click. You don't really have to do any code. You can do it in code, but for UI, usually you wouldn't. Yeah, so wrapping, all that. And so it's very intuitive. Text is very intuitive. For title, usually it's up to you. Some games like to put it here. Wait, drag. Some games put it here, then they'll have their options at the bottom. Some put it in the middle, and they have options in the center. So it's up to you. You can just drag the component where you want it to be. It will scale based on the canvas. So it really doesn't matter. So let's say I want my title to be in the middle. Let's call it Rainbow Game. Yippee. Rainbow Game. And done. You have a title. Simple. Anyone has any questions? you. Okay. And everyone okay? Text, drag, edit. Okay. Next, okay, buttons. Buttons are a bit more complicated. So to create a button, same, right-click hierarchy, UI canvas, find the button option here, button, and you can name it whatever you want. I'm gonna call it the play button, play game button. And then for a button, it's a bit different compared to your other components. It will have two. The main component, which is the parent, it will have this button component. The text is just the text, the name of the button. So, okay, let me double click. You'll see now my button just says button. So you can go to the text component, change it to say something else like play. And there you go, you have a button. It's clickable too. So if I play, oh, I have an error. Oh, sorry. Compile. Okay, let's play. You can see my button is being pressed. It has that button clicking effect. You can change some of the effects here. So on press, if I press, let's say I want to make it red. On selected, I'm pretty sure it's like hovering, I think. Yeah. Okay, on selected is after you click, what is the color? On disabled is if you disable the button, let's make it blue, for example. If I disable the button, okay, can't really see. Okay, and highlighted, if I believe should be hovered. If you hover over the button, oh, I disabled it. Oops. Okay. Okay, highlighting doesn't work for me either. Normal color is just before you press it. So here, let's make it light blue. Okay, so you can go and play around with the options, quite intuitive. Okay, so just like text, it's like Google Doc. If you have ever used any document software, you can just scale it by dragging and dropping, or dragging it to your heart's content. So you can drag it, make it bigger. So on the game, it'll look bigger. So simple, buttons, very simple. The difficult part is making your buttons do something. So you have to write, this is where you have to write functions again to make your buttons work. Okay, so the visuals, I'll let you guys explore. We'll explore the coding part. So in button, you will see inside the button component, there is this little on click area. So what we're going to do is we're going to click this add to the list, and you'll see now there is an empty object. It's looking for an object or looking for a script to run. Okay, so now I'm going to teach you the conventional way. This is what most people will do. We're going to create an empty object. Let's call it main menu manager. So it's just an empty object, and I'm going to give it a script called main menu manager. So it only has only one new script, main menu manager. Okay, I'll call it 2 because I have one already. Okay, you can create script either by add component, or you can right click your scripts folder or anywhere. Create mono behavior script in menu manager 2. Okay, so don't forget to drag your script into your main menu manager. Here. Okay, so now my main menu manager has one. Okay, then back to your button. What I want you to do is you drag your main menu manager object into the space here. And you'll see this no function suddenly will pop up. So this is essentially how you find functions to run when you click the button. So if you have a script, it will show all of the public functions that can be accessed from the object. So here, yeah, but that is not what we need right now. We haven't written the script that we need. Okay, so okay, let me open main menu manager 2. Okay, so if you open the new script, we are going to delete all these. We don't need that. Okay. So what we need to do is we need to write a function that can be run or invoked when we click the button. So naturally, it has to be a public function, but we don't really need it to return anything. So we just do public void and then we give it a name. So let's say the play button, I want it to transition to a different scene. In other words, I want to change the level to the game. So let's call it on click play button. Oh, autofill, lovely. Okay, so in Unity, all of your level transitions, all of your scene transitions are managed by this one object in Unity. It's called your scene manager. So if you do SceneManager dot, you will see all of the functions related to changing your scenes, loading your scenes. So this is a Unity object. Just have to memorize something called Scene Manager. If you want to be able to find it, you have to upload, import this package using Unity Engine Scene Management, and you'll be able to access this by code. So if I want to load a different scene, we use the load scene function, and it will ask for a name, right? Load scene takes in a string scene name. All you have to put is the name of your scene that you have saved it as in your folder. So for example, in my editor, in my scenes folder, I have a scene called level 1. So literally just copy paste the name of the scene you want to load with space included. Just put it there, and now your function should work. Save, should have no error. So back to the play button. So in this component, we haven't given it the function to run yet. So when the play button is clicked, go to your script that has the function you want to call, and then on click play. So now it will run that function. So if I try, it will load the scene that I have. So this is how you transition levels in your Unity game. Okay? And lastly, if your scene doesn't work, if your scene transition doesn't work, what you need to do is go to Files. So Files in the top right, top left, click Build Profiles or Ctrl-Shift-B. Go to your scene list. All the scenes that can be accessed by your scene manager are all the scenes you put here. So to populate this, all you have to do is drag and drop all the scenes that you want to be found by your scene manager. If, let's say, I remove my level 1 and I try to play the game, I think it will say unable to find scene. But that might be a game thing. Yeah. So I'll get an error. Level 1 couldn't be loaded because it is not in my build profile. It is not in my scene list. So my scene manager cannot find my scene. So don't forget, top left, build profile, scene list. Drag and drop the scenes that you want in your game. So if you have scenes that you use to test your game, you don't have to put it in. This is your final game version. This is the stuff that will be downloaded by your player. If you don't want certain scenes to be found in your final game, don't put them in this list. It will make it more optimized. It will save some space. And remember, the scene at the top is the scene that will be loaded at the very start when your application is open. So if I put level 1 as my first scene, okay, if I drag it on top, if I build this as an exe and I download it, level 1 will be played, it will skip my main menu. So make sure it is in order. Usually just make sure the first scene at the very top is the scene that you want to be seen. So usually your main menu. Okay, that should be, so if I do that, click, play, it should work. So I can play my game here. Then, so that is literally the basics of UI UX in Unity. Now that you know how to put text, you know how to put buttons, you know how to change images and make backgrounds, you can literally make any UI you want. It really just takes time after that and design. Okay, so anyone need help? Okay, I'll walk around now. So slides, main menu manager, something the place. Give it a component, look for the button, drag, click, find the function, the scene list, and that's it. Okay, lovely. Okay. I walk around a bit. Yeah, what's wrong? What's up? Okay, so you need to drag something that is alive in your hierarchy. So try we put it in an object. So if you drag the object, it should work. Don't drag the script because your on-click functions try to find stuff that is alive in your scene. Your script doesn't live statically. Yeah, okay, so it should work now. Then don't forget to add the scene into your scene list and it should be fine.
Isn't a scene in here?
So there's a build profile.
Yeah.
Yeah. So file, build profile.
So I'm
So scene list. So you add all the scenes that you want in your final game into that list. So the scene list is where your scene manager object will get access.
just trying to
Yep, just drag it in. Yep,
side.
play and then click the button and it should work.
So every time we want like something to be like on click, we have to make an empty and then put that in the first time.
You don't have to make it an empty game object. You can even just put it on the canvas as long as the script exists on a game object. It always looks for an object. Yeah. So screen background stretch and then make everything 0. Yeah, so that's correct. So make everything 0. Okay. What is your screen possible? Why is it? Does your background have a texture? Why is your texture is a font, so it's loading nothing?
Oh, it's because it wasn't white.
You look for like a square or like a white texture or something. Yeah. Usually I recommend not using raw image because it's a bit tricky. Yeah, but it works. Huh?
You know what's this? This
Okay. Oh, hold on. Canvas. Why do you have?
I don't know what that thing is. It's just there since today.
What is that thing? Is this your input? You have a new input system.
I mean, I made that in another game.
Mm-hmm.
It should not be here.
It should not. This should not show up. No idea what that line is. I suspect it is just the input manager logo,
Okay.
but it shouldn't. I don't think it will appear in the final game. But there's still a line. It could be your image. Your image could just be missing the pixels
Oh,
when it's stretched out.
okay.
I think that's possible.
No, but then
It's not. Okay.
even when you, yeah, the image should not have that actually.
Yeah. Okay. It's a little weird. I'm not too sure actually. Yeah. Can you try changing this to a normal image instead of a texture? Yeah, so not raw image, just image. And then you see if that component works better.
It should not be in the button, right? Troy?
Okay, let's just see if it works. I turn off background, will the line go away? Okay, so it's not even the line issue.
Oh, yeah.
It is in your canvas somewhere. Something in your canvas is showing up. What is it? No idea. I don't know. I think it is rendering this. I think it's rendering the canvas border.
Oh, this thing.
Yeah, but it shouldn't. That shouldn't happen at all.
Oh yeah, it's
Yeah, okay. That shouldn't happen at all. By right.
Yeah.
Likely, maybe it's a gizmo. Your gizmo is being shown. Okay, there's too many options. Where is your canvas? Yeah, the lines are gone now.
Okay, it was a.
Yeah, but I don't think it will show up.
Thank you.
Yeah.
Yes.
Hello. What's up?
But then press play and just like
Oh, why?
press that fix.
Okay. Okay, I see. I know. Let me see your code. Okay, yeah. So if you do multiply time.delta time, multiply, what's your multiply? So just add time.delta time. Yeah, it should work. You weren't here last week, so you didn't see the explanation. Okay. Okay, thanks for coming. Okay, so this is it's already 9:30, so I'm not gonna keep you here. If there was time, I was going to go through a score system so you guys can try to make how to show the UI with the score, but there's no time. So I'll probably carry on next week. There's also something about input system. A lot of you asked me how to put controller support. I was gonna go through input system. So I'll push that to like week 4 or 5, I think. Yeah. But for now, that's the end. So we covered quite a bit. We covered collisions, colliders, how to make things touch, when things touch, how do things happen, functions, how to write basic functions, how to find references, how to update other game objects using a script that is not on the game object, touched a bit on UI, level transition, and that's actually a lot of foundation for your small games. So from now on, if you guys are interested, you guys should have enough knowledge to follow any YouTube tutorial on Unity to find a specific type of game you're trying to make. So if you are interested, you guys can go and start working on it at home. Otherwise, you can join me next week. I'll probably cover a bit more on physics and more UI, more advanced UI stuff and the score manager. Yeah. Yeah. So if you have nothing left, you guys are free to go. I'll be here until 10, like last week. If you have any questions, you want to implement anything not in the slides, let me know. I'll help you. Any ideas? Yeah. So the room is open until 10. Feel free to stay back if you want to continue adding stuff to your game. And yeah, thank you for coming. Workshop.